So, check, mic check. You guys hear me okay? Maybe a little louder. We good? Mic check? Okay. So reasons to pay attention. One is I'm a little delirious from lack of good sleep for the last couple of nights. I don't know how many other people are severely displaced from their home time zone, but I may make bad decisions, so that should make this entertaining. Another thing is I've got 2 live demos that I'm going to attempt, and the last couple of times I tried them, they didn't work. So that should make it entertaining too, because that's always, it's like going to the racetrack. You might see a crash. So we'll try and keep this interactive. Here's my bad jet lag joke. What's the definition of jet lag? I'm sorry, what were we talking about? Thanks for laughing for that. So my name's Jody. I work for CyberArk. CyberArk's an almost 20-year-old company focused on privileged access management. That is, people with root passwords, the things with root passwords now. And so traditionally that was people, but more and more it's processes, it's tools. And so the gist of this presentation is how do we secure that automation? How do we handle these privileged actors? And then there's something called the secret zero problem. It goes by other names, auto-enrollment, but how do you bootstrap identity so that you can authenticate, authorize, and audit these things that are doing work? But to just kind of do a history lesson, and I'm noticing some themes here, so I won't dwell on some of the slides that I've seen, the topics kind of covered, because I think, we're seeing a lot of consistency, which is good. Everybody's on message, even though we're not collaborating around this. But 8 years ago, when DevOps was a new thing, I used to use the graphic on the left to try and explain what it was to people and just say, really it's about change at speed. And development had developed ways to introduce change using agile development and things like that. So they used to be the constraint. That constraint then moved to operations. Operations wasn't ready. They had SLAs they had to meet. They had really good reasons for saying, hey, whoa, slow down. And DevOps, there was a wall of confusion between Dev and Ops. But if we fast forward about 8 years, and it's not, we can't call victory yet, but techniques have been developed to do change at scale and speed. Dev and Ops have gotten together and done things like blue-green deployments, dark deployments, feature switches, and just a lot of new techniques have been developed to introduce change at scale and speed. And now we have the situation that you see over there on the right, where there's a new constraint, and that is, how do we do it securely? How do we do it in such a way that it can be authenticated, authorized, and audited? And this is why we have this conference, right? So everybody's probably read the Phoenix Project or the Goal and probably knows something about the theory of constraints. And what happens with constraints is sometimes you just work around them. And so this is part of the challenge here. And I had to point out in another presentation with this is not a real book. You can't go buy this anywhere. This is supposed to be a humorous attempt, and it's documenting kind of a true situation. And that is, like we had with Shadow IT, if there is a constraint, the tendency is to try and work around it. And so this is what we don't want. And I appreciated Francois's call to collaboration, because I think collaboration, fundamentally that's what DevOps was about. And so this is what we need to do now, because this is a report from Gartner that I think you can get on Sonatype's website. And if Gartner says it, it must be true, right? So that's why we put Gartner quotes in our presentations. But top complaint or top thing to get right in 2018 is DevOps collaborating with the security team. So collaboration is number 1, but it's also number 7, and it's also number 11. Collaborating with the compliance team, collaborating with the audit team. So DevOps has gotten real, and it's gotten mature enough where now they're saying, okay, great, you can do change at scale and speed. Now you need to do it securely. And it's not just the applications. It's not delivering the secure applications. It's delivering applications securely. And that's what I'm really talking about here, is securing the pipeline, not securing the contents of the pipeline. It's not application security. It's DevOps pipeline security. So if we look at the personas that are involved here, there's really 3 major personas. There is the security team, which needs controls, and to prove controls are effective. And that's the basics of compliance. So it's not enough to have controls. If you can't prove that they're effective, do you really have controls if you can't prove it? It's like the tree falling in the forest, right? the DevOps team, they're all good at change at scale and speed, and they're generally on board with the concepts of security. So in our experience, it's not that the DevOps team is cavalier, even though that book is kind of funny. They're not cavalier about security. It's just that the security team hasn't caught up with the way that operations wasn't ready for the changes that the dev team was introducing. The security team hasn't caught up with this new reality, and so you've got this wall of confusion going on. So the third persona here are the developers. And developers, generally speaking, want as little to do with security as possible. And we kind of don't want to put the onus of security on them. I don't know if anybody was at AWS reInvent, but Werner Vogels was saying security is everybody's business. Yeah, it's important, but it's not really everybody's business. And the less onus we can put on developers to be responsible for security, the more compliance we'll probably have. Make the right thing to do, the easy thing to do. That's a thing. So there's our personas. If we look at how DevOps has de-risked change, it's by reducing the quanta of change. As the speed has increased, the quanta has shrunk. And so as we've gotten new technologies, first with virtualization, then with containers, and now with serverless and microservices, you de-risk change because the size of the change is smaller. And it also enables other things like parallel development, parallel deployments. It enables a lot of other capabilities. But the point is now we have a lot more things to keep track of. And so a lot of these things need access to databases and services and other things. They need access to the secrets and the credentials in order to get access to these services. So how do we provision these things? How do we keep track of them? There's too many for people to keep up with anymore. And that's why we have so much automation. And we all know DevOps isn't automation, but you can't really do DevOps without automation, right? So now we have these privileged actors in the network. We've got truly robotic system administrators that are provisioning servers, configuring servers, deploying applications. These are your system administrators in many ways now. And we need to keep track of what they're doing. We need to know what they're doing. We need to authenticate, authorize, and all their activity. So especially these automation tools that are doing that, but across the board. Scanning. Scanning is typically a very privileged process because it has to reach in and see what's going on everywhere in the network. And so that is a very privileged process. So this is the general problem that we find today. And to the DevOps team's credits, people generally aren't embedding secrets in source code anymore. That's kind of the first step. The first step is get your secrets out of source code. I'm not going to ask for a show of hands, but if you have secrets in source code, get them out. Find a place to put them. Because the first, many of the breaches that you hear about today, the Uber and things like that, these secrets were harvested out of GitHub. They were just there for the taking. And so that's the first step. Get your secrets, your embedded secrets out. If a secret is embedded in source code, it can be rotated. And rotation is the first order of hygiene for any credential. The sooner, the more you rotate, the less valuable that credential is because it's likely to be no good when somebody goes to use it. So for a lot of reasons, you want to get secrets out of source code. So a lot of DevOps teams say, hey, we're using Puppet. Puppet has hybrid database and encrypted YAML. We'll put our secrets there. And then there's another team that's using Chef. And they say, hey, Chef has data bags. We'll put our secrets there. And another team's using Vault. And another team's using AWS. And another team's using PCF. We'll put it in CredHub. So now you've got secret sprawl. This is you've heard of image sprawl. There's different kinds of sprawl. Now you have secret sprawl. And you've got these secrets cached in all these different places, many of which really aren't secure. So they're a place to store the secrets, and yeah, they're not in source code anymore. But now you've got this balkanized, fractured, very exposed sets of secrets spread across your operations. So this is what we call islands of trust. So again, it's better than, but this is the next step of maturity. Okay, now we've got secrets here, but now we've got this fractured security space. We don't have good, consistent practices. We can't really audit these things. The security team is saying, the security's like, we got to get these horses back in the stable, help, And so a lot of times we come in and we have meetings with the DevOps teams and the security teams in the same room, and it's like marriage counseling. It's like, no, see, the DevOps team is adding value to the business. And security, DevOps, they need compliance because the auditors are going to come calling. And so it's like, trying to see, everybody see things from their other point of view. But the other part of this is, even if you unify all this, even if you get one secret store for all your DevOps stuff, if it's not integrated with your enterprise security processes, you still got a problem. You still don't have coherence and unity. And that's really what we're trying to get to. So factors that increase the per capita cost of a breach. So this is kind of a funny graph. This is the bottom part of it. The top part was, things that decreased the cost of so reduce the cost of a breach. And these are good practices. These are the negative practices. So a negative decrease is an increase. So this is, and per capita means per compromised record. So what this is saying is that there's a strong correlation between compliance failures and extensive cloud migration and an increased cost of a breach to the tune of $14 US per compromised record. So if you have 30 million compromised records times 14, this is the negative thing. And we're not seeing DevOps up here, but there's a pretty strong correlation between cloud migration and DevOps. They're not, completely orthogonal. They're not completely correlated, but people that tend to be doing cloud are doing DevOps. But at the very least, compliance failures, if you can't show compliance, if you can't show you've got good controls in place, then we're seeing this correlation here. So anyway, so here's a question. Can you be a hacker if you're not wearing a hoodie? It's like, Mr. Robot, it's like when I'm at home, I have a hoodie and I was like, look to my wife, I was like, look honey, I'm a hacker. Now I'm a hipster. Now I'm a hacker. But she doesn't think that's funny anymore. Anyway, so these credentials that are stored in these various places are ripe for the picking. And this used to be kind of a hypothetical. We know about GitHub and things like that, but I hadn't seen any really intentional targeting of these systems until literally last week. A friend of mine sent me a link to this video on YouTube from DevCon in October. And it was a guy, this is a white hat hacker, so this is a good guy. But he was documenting how to exploit continuous build systems or continuous integration systems. And he was not only documenting them, he's got a framework on GitHub that teaches you how to do it. And it's adding to it. And so this is, so the first order of business is you identify the exploit and then you figure out how to defend against it. So he's doing the right thing. But he's calling attention to the fact, that before it was kind of us going, hey, this could be a problem. It's a problem. It's a true problem. And he makes some really good points here, which I just love because they dovetail very nicely with my presentation. But here's all the good things. I don't know if anybody can read this at the back, so I'll just read it to you. Good. Frequent release cycles are fabulous. Good. Faster code deployment equals quick remediation. Good. Decoupled systems reduce single points of failure. Compromise of one service doesn't always mean full ownage. Bad. Fast release sometimes mean hasty oversights. You're doing things too quickly to really do them right. Automated deployment systems are checked less than the code that they deploy. So this, so much focus on AppSec and security scanning, let's not forget that the things that are deploying these apps are privileged processes, and they bear looking at. And the last thing here, which is really the thesis statement of this whole presentation, is identity management. So the point I'm going to leave you with, I'm going to tell you what I'm going to leave you with now, and then I'm going to do the rest of the presentation. But I think identity management is the common ground that DevOps and security can focus on. It's a common language. It's a way to say, what is the identity that this process is running at? What is the identity of this Jenkins executor? What is the identity of these, who needs to be running this playbook in Ansible? And so if you can start focusing on identity and the roles that these identities need to take, then you can start developing a common language. Look, he's a hacker. You're a hacker. Really cold. All right. So anyway, this if you want to go see this video, it's pretty entertaining. There's your link there, your bit.ly link. So anyway, so we talked about that, and there's the link there too. Guy goes by Spacebox. That's a capital B, 0 box. So we've got these challenges. We've got security teams not collaborating effectively, exploitive automation deployments, inconsistency and secret sprawl, lack of audit and compliance, broadened attack surface. Let's call it what it is. It's debt. It's technical security debt. And this is going to grow the longer it goes unaddressed. So you really need to start taking a look at it and saying, okay, what are the privileges that these processes need? How are we going to control those? How are we going to audit them and show compliance with our policies? So let's look at, just to put some nomenclature around this, we're seeing a very high, I mean, almost everybody relates to this. Almost everybody's using Jenkins for build, and a lot of people more and more people increasingly are using Ansible for deployments. Some people use Jenkins for deployments, and that's one of the challenges of our job is no two DevOps tool chains are the same, and certainly no workflows are the same. So our first step is always just understanding what the workflow is. But in general, you've got these privileged systems that are building the applications, and they need access to the secrets to be able to pull code from GitHub, to deploy to the Docker repo for testing, to deploy the artifact repository for staging. And then Ansible similarly needs secrets to pull from the repository to deploy the application. Similarly, the applications also need access to secrets to do their work. So we've got two sets of identities at different times, identities in the tool chain and then identities at runtime. The point is, all of these things, in order to get access to these credentials, need to be able to pull secrets from some secret store, and preferably they're authenticated and authorized and audited in doing that. So that sets us up for, let's talk about identity. And let's talk about identities that aren't just people. Let's talk about machine identity or service identity, or see the term now, workload identity. These are the non-human identities that still need to be authenticated, authorized, and audited. We want to do it all with code. We need to do it very efficiently because we've got thousands of things coming and going. So this has to be a very efficient and dynamic process. So this is a taxonomy of different ways of doing authentication, and it's my work. As you won't find a reference for this anywhere. It's just based on my experience. So generally, we've got two classes of authentication techniques. One is credential-based, which is your classic username and password, hostname API key. So everybody's familiar with that. I won't dwell on that too much. But there are differences in the machine space, and because these things come up and they don't, the enrollment process is it's not well established. Think about the human workflow of identity. You start a job, they know who you are, you get assigned an account, you get a password, you remember the password, hopefully, and so you have your own built-in vault so you can remember your password. These things don't apply to machines in general. They don't know their own passwords, and they come and go at such a furious rate that you really need something that's very, very efficient for doing that. So there's pre-verified machine identity techniques, and then there's dynamically verified techniques. I'm going to do a demo. The first demo I'm going to do is this more statically defined identity, where we assign an identity, and there's a privileged process that issues the API keys. And so we'll show what that looks like, God willing, that the demos work. The other thing is attribute-based. And so this is a new, so think about biometrics. The human analog here is, when you go to open your phone, you don't use a code, you don't type in a code, you just use your thumbprint. So it's something about you. It's not something that you remember or submit. And so this is getting into a more advanced way of authenticating these non-human entities, but it also has some limitations. And these limitations are kind of spelled out here. We actually do this. One of our products has been doing this for over 10 years, but it requires an agent be co-located with the application in order to do the verification. But it can do things like use certs or MD5 hashes to authenticate the application, verify it is what it is without the application submitting a password. So the other here, and the demo I'm going to do second, is using Kubernetes and using the Kubernetes runtime to verify the attributes of a container requesting access to secrets. So this is the kind of bootstrap process. You have to authenticate in order to get access to the secrets. Once you have access to the secrets, then you can get access to the databases and the services that you need. We all good with that? Any questions? All right. So let's see what happens. This is going to be the fun part. Oh, never mind. Let me just step you through. Let me show you what I'm going to show you, then I'll show you. So credential-based pre-verified identity. So the workflow here is that there's an admin process that issues the API application container. So it's going to launch the containers, and then it's going to assign each of these containers an API key. And they're all going to have the same API key. They're going to share the same identity. So the applications will retrieve the API key from the shared volume, just running in a Docker Compose environment. And then the credential is deleted from the shared volume after 5 seconds. So it only exists for 5 seconds. And this is where you start saying, okay, thinking like an attacker, how could this system be compromised? How could somebody get access to this API key? Because when they have that API key, then they can retrieve whatever credentials that identity is authorized to retrieve. So this is a way of distributing the API key pretty securely. It's a shared volume that's only seen by these containers, and it's deleted after 5 seconds. Here's a graphical depiction of that same thing. So the issuing authority, or the credential issuing authority, is this script, and it's going to be logged in as the DevOps administrator. So it's a privileged authority. It has to have the privilege to be able to rotate the API key to sign these things. So it's going to pull the API key from the secret store, actually rotate it, distribute it in the shared volume. The applications pick that up. So that's probably enough ado about that. Now let's see if it actually works. So I'm going to run 2 containers, and they're going to sleep every 5 seconds before they fetch that database password. So anybody use WeScope? WeScope makes demos a whole lot more interesting because you can actually see what's going on as opposed to just watch text scroll. So this is my Conjur environment. Conjur's our secrets management product for DevOps workflows. We've got a booth out there. And here's my 2 containers that came up, Web App 1, Web App 2. I can open up these containers, get a shell in here and pop this out and just watch as it retrieves these passwords. So I'm going to just tail this log file that it writes to and watch. So we can see that it's got the API key. It echoes the API key to the log. And it's retrieving the password, which is unimaginatively the database password. So all well and good. I mean, that's great, right? It's so what? So let's do something here now. And this is, what I'm going to do is just cat this script. So this is the script that's going to cycle or rotate that API key. And so rotation, again, this is like the most fundamental security hygiene practice you can have. As soon as you rotate a credential, anybody that has the old credential is out. They're locked out. No matter where they are, it's like an EMP for credentials. You rotate the password, and then all those old credentials are dead. So what this script does is rotates the API key, and if I don't give it an argument, then it'll write the new API key to the shared volume. The applications will pick it up, and they'll go on about their business. And so we'll see that happen in real time here. It will rotate the API key. The application, it failed authentication, went back to look at that shared volume, picked up the API key, and then the script deleted it. So that's cool. And then here's just the other example where if I add an argument, it's not going to write that API key back, and the applications are locked out. And because all these applications are sharing the same identity, which is arguably what you want, because they all have the same privilege. They're all instances of the same image. They all have the same authorization requirements. So you don't need to create unique identities for every single container. So these are sharing very efficiently a single identity. And when I rotate that API key, they're all locked out. So that's just kind of getting into some of the semantics of identity for inanimate things. This is not a human thing anymore. And these cycles, these life cycles, are very dynamic. But the downsides to this is we have this right now the identity that's used to issue these keys is a privileged administrator. And if we had lots of different types of applications, then you get into, well, how much privilege does this thing have, and does it become a liability? Because now it has access to issue credentials, not just use credentials, but issue credentials, which is a very powerful thing. And if you're aware of general exploits using Active Directory, one of the most powerful things you can do is the golden ticket hack, where you take command of the identity issuing authority, and therefore can give yourself any privilege that you want. So we want to avoid that, and this is the kind of critical thinking that needs to go into our security models. And so all the old principles of zero trust, least privilege, non-repudiation, role-based access control, these all still apply, It's just that now they need to apply to these non-human actors. So that's that first demo. Let me just stop these things so I set up for my second demo. Any questions? Is all of this clear and straightforward? Semi-entertaining, maybe? So I'm going to shut these containers down, and we'll move on to the Kubernetes demo. So that's that. So now we're going to look at the attribute-based authentication. So not using a password. The containers are come up, and they initiate the verification of their identity. So they submit a request, basically. And the workflow really is submitting a certificate signing request to now the secret service. So there's no administrator logged in here. This is all fully automated, where as soon as these applications come up, and they can be launched by whatever automated process, but they're not given an identity to start with. They request verification of an identity through a CSR. That CSR is validated with Kubernetes. So basically, we're using Kubernetes as a trusted third party to say, is this thing what it says it is? Is it truly at this IP address? Does it have this name? Is it an instance of this image? And if that all checks out, then we'll issue it a certificate. And that certificate becomes its credential that it can use to authenticate. So that's the process that we're doing here. Here's the graphical representation of that. So this is using in order to hide complexity from the application. Remember that if we're trying to make the developer experience as seamless as possible, we want to shield them from a lot of this, the mechanics of doing this authentication and certification, these things like that. So we're using a sidecar here, which is a very common pattern now with service mesh architectures as a way of encapsulating complexity. So this sidecar container is actually doing the authentication dialogue back and forth with the Conjure server. And it gets back the certificate not directly over the requesting channel, but through a side channel. So we're actually, it's again, so we're kind of a two-factor authentication where the final check is, even if it's not where it says it is, we're writing the cert back to where it says it is into the container using the Kubernetes runtime. So if it successfully spoofed us every other way, it's still not going to get a cert. So that's this demo, and let me just run through that real quick. It's very similar to the one we had before in that we're going to deploy a web application. It's going to come up. It's going to first get authenticated, and usually by the time everything pops up here, it's authenticated and it's already started retrieving the database password. So that's, if you saw those lines get created, that was after it got authenticated. Now it's contacting the secret service to retrieve the database password. Pull this up here, and it will start seeing it echo the database password. So that, same thing there. It got authenticated, got access to the database password, and yay, everything's good. So let me just show you one last thing here real quick, because I want to show you what this certificate looks like, and then talk a little bit about some developing standards that are happening. So need to use web app context control. So live demos are all the rage at the conferences these days. I'm just happy mine, so far, I don't want to jinx it, so far it's worked pretty well. So I'm going to exec into this container, and we're just going to look at that cert real quick. So I'm in the web app container. I happen to know that the cert is written to the Conjure SSL directory. That's here. So here's a cert and the private key that it can use for encryption. And then I'm just going to parse that cert real quick. It's an X509 cert, and it's client tab. It's text. Okay. So final proof point. We've got a cert here, and if we look at just the common name here, it's got the IP address encoded in it. If we look over here, we can see that that's the same IP address that the container is at. So the cool thing about certs is, they're pretty open-ended. We can put a lot of information in this cert, and it's stateless. We're not keeping track of these certs anywhere. They don't have to be looked up. So it's very, very scalable. We can issue these certs they're secure. They can be tagged very specifically to this one container. They can't be used anywhere else. They certainly can't be used outside of Kubernetes, but they can't be used by anything else that doesn't have that information in it. So the thing that we find really gratifying about this, but, besides just being incredibly technical, is that it is very similar to an emerging standard coming out of the Cloud Native Computing Foundation. The same organization that's overseeing Kubernetes is kind of sponsoring this. It's not a formal project yet, but it's a project called SPIFFY, Secure Production Identity Framework for Everybody. So this is a generalization of that process that we just looked at, where a requester asks for verification of its identity. The identity is verified through various means, but generally through a trusted third party. It gets back this specially formatted 509 certificate, which can be used as a general way of authenticating to other processes. And so this is called workload authentication. It's just how do we authenticate these things that aren't people anymore. And so this is a general framework that's being developed for that, for these highly scaled container and dynamic environments. Just to foreshadow on, attribute authentication and the SPIFFY standard are pretty cool, but what if these applications never actually touch credentials? This is some foreshadowing of some research work that we're doing. And it's based on a product that CyberArk has for human administrators, where a sysadmin can log in and never see the root key, but get a root session on a target machine, and that session is audited, but they never see the root password. And so this is a much more secure way to give access, to give privileged access to something. And so what if we could do that for these non-human actors, where an application simply gets a connection to the database and it never sees the database password? We think that's a much more secure way to manage these things. It's also much simpler for the developers. So that's a bit of foreshadowing. That's another presentation for another time. So just to wrap up, strong identity enables collaboration. So I think that starting to talk about the identities of these processes, which ones are more privileged than others, it gives you a way to have this common language that DevOps teams and security teams can start to use to understand the concerns of each other. If you have an overprivileged process, that is a bigger target. It's more of a liability. And so we want to mitigate that risk. We want to, risk is probability times impact. So if that overprivileged process, if it has access to tons and tons of secrets or can issue identities, that's something we really need to focus on and raise its level of importance in terms of our strategy and remediation, as opposed to just some application that needs to connect to a database maybe. So it just gives us a common parlance where security and operations can focus on solving these problems as much as possible, keeping development out of the loop. So just a call to action: collaborate, collaborate, collaborate. Focus on, for the security teams, focus on outcomes. This is how, the marriage counseling slide. Focus on outcomes, recognize the value that DevOps is bringing to the organization, being practical, and making trade-offs between perfect and good enough. Just a case in point, I have a customer whose security team mandated that all Jenkins jobs will be authenticated. And anybody that knows Jenkins knows you can authenticate the executors, but the jobs are data. You can't authenticate data. You can sign data, there's other things you can do, but you can't really authenticate data. So they issued a nonsensical decree that the DevOps teams have no way of complying with. So avoid doing that if you're on the security team. DevOps teams, show you understand security principles, that you believe in those, but be open to change. Recognize that they're required to show compliance with regulations. Use established systems of trust where possible. So tie into the enterprise organization's established systems for authentication, for those things. And then both identity management is a common objective. It's a way of talking about privilege, about overprivilege, about just being able to control access to these credentials and preventing them from getting into the wrong hands. So thanks. I don't know how I'm doing on time. Do we have time for questions, or is there 5 minutes? All right. Any questions? Usually there's somebody in the room that goes, yeah, but what you did there, that could be, Anybody? All right. Great. Thank you.